Hello, can you hear me?
Yes.
Thank you. Okay, once again, good morning, everyone. We will start the webinar shortly. Just a quick reminder for all participants to mute their mic during the presentation. Thank you. If you would like to ask a question during the session, you can do so via the chat box. We will try to answer as many questions as we can at the end of the session. Any questions we do not get a chance to answer will be answered via email after the webinar. And also later, we'll be polling 2 questions along the way. You are strongly encouraged to answer them. Just need to check the box and then submit. It's simple as that. It seems we are ready, so let's get going. Okay, thank you for joining us today. My name is Waiman. I'm the Senior Product Manager of the Products and Marketing team here at Mitsubishi Electric, MEAP in short. I saw some familiar names on the chat box. Thanks for those who have attended our previous webinars. There will be 2 presenters in this webinar, Mr. Tay from the Low Voltage Switchgear Department and myself. We are here to share some smart energy savings and monitoring solutions, which we believe will be beneficial in your area of work, be it factory-related or commercial projects. Hopefully, after this webinar, there will be some useful takeaway for most of you. Okay, please see these 2 photos. What do you see over here? Energy saving. Why should we save energy? Why is energy saving so important for us? Okay, basically energy saving means making effort to reduce the consumption of natural energy resources like electricity, water, and so on. Energy is limited, as we know, and in order to maintain the quality of life, it's important that we use our energy resources wisely. It is also a good way to save money and also reduce environmental harm. So in the context of energy saving concepts that we're going to share today, it encompasses the 4 main points. How to effectively collect the data, how to analyze the data, how to monitor the data, and lastly, how to control the data to your advantage. These 4 points are closely linked with each other. So the first topic for today, energy saving inverters and their smart functions. So I'll be covering these during my course of presentation on the basis of what inverter can do, the key benefits of using drives to users, some of the smart functions of our modern inverters, and lastly, to share some successful references. So before starting the first topic, I would like to share some brief info on our company background. So we are located at Alexandra Road. Mitsubishi Electric is here since 1977. There are various groups in the company, and we belong to the Factory Automation Group. In MEAP, we are actively involved in corporate social responsibility activities in the areas of contribution and engagement activities in education, environment, and philanthropy. Energy saving is a very important DNA in every MEAP employee, and we basically resides on the 3 R's principle: to reuse, reduce, and recycle. Okay, this slide shows the overview of our factories in Japan. On the left side, Nagawa Works manufactures automation products such as PLCs, servos, HMI or touchscreen, EVM and laser machines, robots, as well as inverter. On the right side, it shows the factory from Fukuyama Works. It manufactures circuit breakers and energy saving and measurement devices and so on. Okay, now I would like to go through some fundamentals of inverters. I think most of us know what does inverter do. They basically control the speed of an induction motor. So as you can see over here, the inverter system comprises of 3 main parts. The first part is the AC to DC converter, or we call it the rectifier. Basically, it converts the AC to DC power and then stores the energy in the DC link, which is the second part. In the last portion, basically the inverter converts the DC energy back to AC before going to the motor. So from a layman's point of view, basically you just think of inverter as a AC to DC and then DC back to AC. And basically, it uses the pulse width modulation control principle. Okay, why do we use inverters? How are they called energy saving device? How much do they actually save? Is it meant for short term or long term? So all these are some of the points that the users may ask themselves when they're using to choose whether to use or not to use inverters. So now I would like to introduce a very famous mathematics law called the cubic law for inverters. As you can see over here, the consumed power of a variable torque load such as centrifugal fans, pumps, and blowers is proportional to the cube of its rotational speed. If you see the diagram on the right, it shows the consumed power versus the airflow speed. The dark blue line showing the control using temper, and the dark light blue line showing the use of inverter. And the areas under the curve over here basically is the energy saving. So basically, for a 20% speed reduction, it will be about 50% of reduction in terms of power consumption after using the cubic law. And 50% reduction in power consumption also translates into quite substantial fair bit of energy savings in terms of dollar and cents. Okay, after sharing the cubic law, we now know that inverters can indeed save energy, which in turn energy saving substantially over a 1 year period or even longer. Now I'm going to share with you the list of inverters that Mitsubishi Electric have. Okay, if you can see this diagram, it shows the functions and performance on this axis and the capacity in the horizontal axis. We have the D700 series, E800 series, F series, and the A series. So as you go along this way, the application-wise and performance-wise will need a faster speed inverter, a high-spec inverter, from simple conveyor systems to variable torque applications for HVAC, and also A800 series, basically for the so-called speed, position, and torque control. We now have an extended range of models from A800. It's called the A800 Plus. Basically, all these are using the brains of A800 with customized functions for the crane industry, for roll-to-roll paper, also for elevator drive. And last year, actually, we have the logistic and warehouse model, which I'll be touching on later. So from the user's point of view, they may now understand the various types of inverters are to be used for various types of applications. So if the users are already using non-inverter systems to control their motors for quite some time, it usually takes some good reasons to try to convince them to look into inverters to control their motors. So now we're sharing some of the key benefits to use inverters. First of all is energy savings, which is actually quite obvious, which I shared just now. Energy savings such that because the induction motor is not running at the optimum speed at all times of the day. So at certain points of the day, you need a lower loading conditions. That's the reason why you can use energy saving device such as inverter to run the motor at the required speed at a point of time, which translates into energy saving. Next will be starting current. So when you use the inverter to run the motor, there will be no reduction of any so-called starting current as compared to the conventional methods of using starters such as direct online, Star Delta, or Autotrans. All these starting currents will be eliminated. So it also have impact on the motor itself because the inverter is a device that actually start the motor slowly and stop the motor slowly. Then it gives the motor a longer lifespan, reduce the power line disturbance, and risk of motor damage. And nowadays, in fact, if you know, most of the motors, the inverter-driven type, meaning to say that for very old motors, which has been using for quite some time, you cannot use inverters to control them. So as the inverter technology improves, the motor technology also improves. So as a whole, we try to use the inverter to control the motor in a better way, in a more efficient way to save the energy for the customers. Okay, this slide shows the benefits of using inverters, which I'll be sharing 3 case studies. Okay, so ultimately I want to showcase the annual savings for the customers, which they can be used to reinvest into other things. So the first case on the left side is the water cooling pump for a project. So basically to use the inverter to control and using the conventional way. The second case is actually in the Mitsubishi factory plant. Okay, so using a normal induction motor and a permanent magnet motor, which is higher efficiency. The last one is the application in a commercial building, where there are about 120 units of inverters used for fan control. So we compare using normal induction motor and a high efficiency interior permanent magnet motor, or IPM in short. So as you can see over here, and on the table on the right side, based on the Singapore tariff price of $196 per kilowatt hour. So for the case one, actually we save about 4K. For the second case on the Mitsubishi plant is about 3.3K. And on the last case itself, for the building application, is almost 25K. So all these are because you are not using the motor always running at the optimum speed. You're using the drive to control the speed required depending on the loading conditions, which translates into quite substantial fair bit of energy savings. So in terms of the CO2 emission reduction, in the last case also, it's almost 72.3 tons. So you see, actually, we are very environmental friendly. And use inverters to control, it can bring down actually the carbon dioxide emission also. Okay, after sharing on the basis of inverters and the key benefits of using drive, I will now share some smart functions of a modern drive that we have. Okay, what makes our inverter smart or advanced? If you can see over this diagram, inverters are usually at the plant or shop floor level over here in factories, and they can be connected via different network protocols to the controller level over here. For a smart factory to be achievable, at the edge computing layer over here, the real-time utilization of production shop floor data connectivity with the upper layer can be done. So it's actually easy to achieve optimum efficiency from the plant layer to the enterprise layer. So we actually also work with IT companies such as Google Cloud, okay, Microsoft Azure to actually monitor the data over here. Okay, smart functions of inverters. Our inverters have the Ethernet IP filtering function that prevent unwanted access from external devices. Also, devices which can control the inverter can be limited by setting the IP address range of the inverter drives devices used to operate it. Thirdly, for Ethernet security function, we have communication sockets to prevent unwanted access from outside. Okay, this is showing the 1 gigabit network SysLink IETSN or Modbus TCP. Okay, next point on the smart functions, even if the inverters are located in high place, as you can see over here, this is an application of sailing crane control, which inverters are actually located at very high position. You can use wireless access to make adjustment of the inverter parameters and the inverter monitoring as well. Simultaneous monitoring of multiple axes is possible, and the inverter maintenance such as live diagnosis check is possible. So the inverters can be connected to a software in the monitor itself, and using a wireless LAN point, you can actually do the programming, the monitoring at the computer side. So it's actually enhance the functional safety between humans and the device itself. Okay, next is the built-in PLC function of our inverters. In accordance with the machine specification, users can actually set various operation patterns, inverter movement at the input over here, the outputs and the status, and also the monitor outputs. So operation of the system can be customized by the inverter alone without using an external PLC. Okay, so in this inverter built-in PLC, the parameters and the setting of frequency can be done at the program. Control programs can actually be created in sequence ladders, using the inverter setup software, FR configurator tool. So almost all the inverter IOs are within the built-in PLC, and this PLC supports up to 6K programming steps and exactly the same type of programming structure as a PLC itself. So the next few slides I'll be touching on the smart functions in the areas of improved maintainability. Okay, as you can see this slide over here, when you see this world's first corrosive attack level alert system, what does it mean? Okay, we are actually very proud to have this world's first corrosive attack level alert system drive. It makes it possible for the users to identify signs of inverter damage caused by corrosive gas such as hydrogen sulfide. This is our patent since September 2019. And in future, all our next generation inverter drives will all have this built-in function. So equipment downtime will be reduced as this function will actually inform the operators when the production environment needs to be improved. Okay, so the combined resistance of multiple metal corrosion sensors is measured to detect the level of degree of metal part corrosive caused by the gas. Okay, so normally in sewage treatment plant, you may have some issues on this corrosive environment. So we do support the customers in this area where we have this so-called corrosive alert system itself. Another areas in improved maintainability is also we can support schedule maintenance planning. Okay, we have these live check functions. In this area, we have actually enhanced this function in the sense that the design life of the cooling fans and the capacitors have been extended to 10 years. Okay, so as you can see this diagram over here, it comprises the inverter's key components such as the cooling fan, control circuit capacitor, the metal corrosion sensor, power module, the main circuit capacitor, and the relays. So the customers can know how long has this parts been running, so they can make a schedule maintenance to actually get in a new drive to replace when the parts are almost near the limit of the lifespan. So this enhanced live check function is very good for the users in the areas of facilities management. Okay, next in the areas of improved maintainability is also we have this real-time monitoring for early fault detection. Okay, so for example, when a mechanical fault such as filter clogging occurs, the inverter outputs a warning or shut off the output to prevent system damage. This shows the top versus output frequency curve. So by default, there is a standard speed torque characteristic stored when there's no fault occurs. So when actually there's a fault occurs, it actually will be falling out of the bandwidth. Then the inverters will actually output an error. So the people doing maintenance, they can go straight to the system to check the system. So similarly, for faults caused by stiff rotation of motor shaft due to increased load or cracks in the fan belt, decreased load can be detected through the motor output current. Okay, next, another areas of smart functions in terms of improved maintainability is AI technology. Okay, so in Mitsubishi, this troubleshooting is supported by our very own AI. We call it MySat. You can see over here. MySat is Mitsubishi Electric's AI technology. It creates the state-of-the-art in technology. This means it's using our proprietary AI technology to make everything, to make every system smarter. Okay, so as you can see over here, when the drive actually trips, there'll be a fault occurs. You will see the error code, and the system can actually allow you to do corrective action. You can know the cause of the fault also. So as you can see over this screen over here, it shows the example of a EOC1. EOC1 is actually overcurrent during acceleration. Okay, so you can see the fault occurs at what time, and the fault diagnosis function, and the users can actually do the so-called troubleshooting easier. So these functions actually can be very, very useful for people in FM also without any special skills, which contributes to severe downtime reduction. Okay, the work efficiency can be further improved for each of the design, operation, and maintenance process through the inverter setup software, the FR Configurator tool. Okay, on this site over here, you can actually download the software from our FA Global website. It's actually there's a free trial version. So some of the functions available are over here. Okay, on the right side is actually the screen showing a live diagnostic check. So the users can know the parts service life in the window also. How long has the parts been in inverter? And there's a warning icon shown in the alarm field of the parts recommended for replacement. So it's also a very good way how to improve maintainability, okay, to replace the parts when it's needed. Okay, next we're touching on the so-called mobile app, as you can see over here. So just now I mentioned about wireless access from inverters from remote location. So now users can also monitor the inverter operation, such as the running frequency, the status, output, all through the mobile app. Okay, now we are having two systems to support it, the Android and the iOS Apple. So in this screen itself, actually you can be able to know the full range of inverters for this application, for this project. And we know the parameters for individual drive, and we can actually check the fault history. So users are very keen to know what are the past faults that they have, so they may actually take a note on this concern. Okay, and lastly is the monitor of the data itself on the drive output current, the voltage. All these are actually important and can be done now through the mobile app. Okay, another area of improved maintainability is how users can use the inverters to add interactive values to their system, which now brings me to the GOT Easy Drive solutions. What does GOT means? It means graphical operator terminal, or now we call it HMI, okay, touchscreen. So basic idea is for the inverter to be connected to the GOT drive for more interactive solution. So the key benefits from a end user point of view is there's no cost increase during startup or adjustment. So in terms of operation, actually it improves the visualization, traceability, and in the areas of maintenance, quicker troubleshooting without the use of personal PC, and predictive and preventive maintenance of the whole system can be done easily. Okay, there are a few kinds of GOT drive configuration. In here, I'll be sharing two cases. On the left side, basically is a direct connection with Ethernet. All these are the models supported using Ethernet, connected to the hub, and then via Ethernet to the touchscreen itself. The second case, we are using the CC-Link IE field, which is a 1 gigabit second network going through a PLC and then going through the Ethernet as well to the GOT itself. So in both cases, the GOT itself enhance the visualization and traceability and allows quicker troubleshooting to improve the areas of maintenance. So we'll be pushing this concept very much to customers which require this solution. Okay, next I'll be sharing some useful drive configurations which may be interest to some of you. So this slide shows the parallel drive. Okay, what is parallel drive? Okay, firstly, for this case, if you notice, some of the motors are more than 1 megawatt. So Mitsubishi Electric doesn't have a very big single unit drive itself. So we have to use this parallel drive solution. 2 to 3 inverters can be connected in parallel, as you can see over here. So the speed is internally synchronized using RS-485. And one good benefit of the system is that should one set of inverter and the converter fail, the system can still run, but at reduced load. Okay, so all these are designed for 400 volt and 690 volt, and all these are air-cooled drives. Okay, so basically now we can use this parallel drive for applications in marine sector, in water treatment, where they have very, very big motor. Okay, this case show the one of the success that we have, though the parallel drive inverters are released not long ago. Okay, basically, this is the application for a chiller compressor project in China. So basically, the motor is 800 kilowatt. So in this application, they are using two numbers of 500 kilowatt of inverters and converters in parallel. Okay, this one shows the picture of the chiller compressor. So next, I'll be touching on another configuration, back to back. Okay, what does back-to-back configuration means? Okay, the inverter can be configured as a back-to-back system using two 6-pulse unit, the A842. So the A series can be used as a regenerative PWM converter with internal option unit. And also the other purpose of using this back-to-back configuration is to use it as a low harmonic unit. Basically, at this point, the inverter input, we want to have the compliance to THDI, the total harmonic current distortion, to be 5%. So in such configuration, basically two main purpose. One is for regen, one is for the low harmonic purpose. Right. Over the years, our A800 series has undergone a lot of new developments to cater for increasing customers' needs. In the A800 Plus drives, now we have the crane application, roller-to-roller, elevator. So now we also rename the A800 series to A800 Plus. Okay, this plus means added-on functions to the flagship model A800 that address the customer's needs in the areas of cranes, tension torque related application. In late December last year, another new series, the AWH model, is launched for the use of applications in logistics and warehousing. Okay, this slide shows the typical distribution warehouse. Where you can see the conveyors in the over here, followed by stacker crane. This is the sorting system. On this side, showing the monitoring system of the whole entire warehouse. So in this form of distribution warehouse, the stackers, the conveyors, sorting system must all operate together in a single system. So there's a need for high speed, efficiency, and shorter downtime in each process. Mitsubishi Electric's eFactory products, including inverters, supports the smooth distribution with high-speed sorting system, promotion of automation, predictive maintenance using remote monitoring, and also other innovative features. Okay, the A800WH model are used for the stacker crane systems, where basically it controls 3 axes, the lift axis, the forks axis, and also the travel axis to store and retrieve goods quickly and steadily in automated warehouse. The inverter is used to stop the shuttle car exactly at the intended position with its full loop control to detect the actual position. Okay, another use for the AWH model is in the areas of ASRS systems, which stands for Automated Storage and Retrieval Systems. Basically, for this lifter and shuttle system over here, the fork of the logistics and transport equipment is moved based on the set frequency, while the start command is given through communication. Okay, the 3 inverters are used to control the travel, fork, and the lift axis. So now it's actually possible with some changes to the system configuration, 2 inverters can be used to control 3 axes. Okay, so by doing this way, it also contributes to the cost reduction. Okay, next, on the regenerative solutions. Okay, if you can see this picture over here, and if you ever wondered how can the inverter save energy when it is actually decelerating. Okay, so we have these saving solutions called power regen solution. So basically, when the inverter is decelerating, is actually the motor is actually acting as a generator. So now if we use a device, we call it a multifunction regeneration converter, the FRXC over here. So the power returned from an inverter can actually be supplied to another inverter, which in terms save energy. So in Japan, for for our these high-speed trains or Shinkansen, which are commonly used. So they are using this type of power regen technology also to actually save the energy and make sure that the energy during deceleration will not be lost. Okay, next I'll be sharing some key success that we have in the years. So basically on the left side is showing the application on parcel sorting and tracking. So basically for these conveyor systems and the sorting system, we are using the D700 series. Okay, for the picture over here, it shows the airport aerobridge control systems for local and also projects in Thailand and Taiwan. So we are actually using these A800 and the E700 models. Lastly, on the top right-hand side is application for a spray painting transfer system for automotive customer. So we are using a lot of A series and E700 series for this type of application. So in terms of application-wise, be it in the factory automation related application, or be it in the HVAC systems, or in the water related applications, so we are able to provide you the correct inverter for your application. Right, so hopefully you have a good first half session of sharing from me on this Friday morning. Thank you. So in summary, my presentation today includes some of the key smart functions which I shared just now, which includes built-in PLC, the wireless connectivity, the networks, the improved maintainability in the areas of predictive and preventive maintenance. And we now know that inverters are a key energy saving device for motor application, and different range of inverters are able to address different applications. Hopefully you have some good takeaways from this. So once again, thank you for your attention, and I will be back for the Q&A later. So as I mentioned earlier just now on the polling of questions, if you notice the chat box, currently we have already posted one question related to my presentation. So you are strongly encouraged to select the most appropriate answer. So at the end of the webinar, we'll be sharing with you the polling results. Okay, so now I should invite Mr. Tay, my colleague from the low voltage switchgear department, to share with us his topic on smart energy monitoring solutions. Please hold on for a while.
Hello, good morning. I'm Tay from LVS department. Thank you very much for attending our webinar. So today's content for our site, we would like to showcase the different type of energy monitoring solution for your needs, and how to collect, analyze, and control data for the energy monitoring solutions. And we would also like to showcase how our Mitsubishi Electric products can be incorporated into this solution to meet your needs. So as per my colleague Waiman, just now he has shared a lot of information regarding energy saving and all the various equipments that has show the importance of energy saving. So we would also like to highlight to you that we have noticed over the years the increasing trend of electrical usage from 2016 all the way to 2019. As you can see here, the rate of energy usage has been increasing, and we would like to highlight to users that what is the cause of increase in the usage of rising costs. It is the importance to have, as users, we would like to showcase the importance that this, to combat this rise in cost of electrical tariffs, we as users also have a part to play, and to do so, we would like to reduce the energy consumption and also to monitor the energy consumption that has to help us to do energy saving. So moving from here, all of us knows that the cost of electricity is rising, right? We should do a part to reduce our usage, but how do we actually reduce our usage? Without knowing how to monitor, it is very difficult for us to know how our energy usage has gone. So from this slide, we can see that all of us are trying to reduce the consumption of energy, and to do so, we would like to appeal to all of you to consider a few points. First, how to collect the data from here. Could our system also do a analysis of our energy usage? And most importantly, is there a possibility to do the control of this usage? So in our visits to our customers, the first questions that we do have, some of the customers do request to us is, how do I go about collection of data? So in the case of a non-ferrous manufacturer, you can see here our customer has actually requested us to do a simple monitoring to monitor the actual conditions. And the customer has also a request for us to manage the data using the SD card. So is that a possibility? Yes, we have actually done such a project for the process automation facility in Singapore, where we have actually came out with an eco-monitor system. Together, we have linked the eco-monitor system to the usage of the switchboards, as well as we have, after the linkage has been done using RS-485 communication, we have actually managed to link the system through the software, as you can see, of this entire layout. So what does our eco-monitor do? Our eco-monitor is a measuring unit which is used as a device to help to measure. And the three main points that we want to focus of our eco-monitor is a phase expansion of energy saving system. Our eco-monitor also allows us to do a leakage current monitoring, as well as our eco-monitor allows us to do simple management of measurement data with prepared forms and graphs. So as you can see here, some of the customers, they will ask us, hey, after we install this product, can we actually monitor the software? Is it free? So yes, we would also like to highlight that after the customer has purchased this product, it comes with a free monitoring software, as well as it allows us to record our data using an SD card. So actually, by doing this installation, the customer saves money by not having to purchase additional software, yet at the same time, they can also do energy monitoring, and also they can do logging of the data. So with this example, you can see the from this product, you can see that there is a control done for this particular product. And we then move on to some customers who actually do request for a more advanced energy monitoring solution. So this advanced monitoring solution, customer will ask us, hey, can I, besides doing control, can I also do visualization and analyze of data? Because some of us do have cases where we have KPIs to meet. So this is another question that has been posed to us by our customers. And we do have another customer in KL where we have visited them, and we have came out a solution with them using an eco-monitor system, a power meter, and we also do have the eco-advisor solution. So you may be wondering, what are all these products all about? So we do have our power meters here, which is the basic monitoring device where we can actually do monitoring of our ampere, of our voltage, of our watt, and our kilowatt. So the kilowatt hour is the measuring point where we can actually do the energy consumption. And our power meters are actually having a good function of having a class 0.5, as well as we do have a high performance standard and the economy type, where our high performance allows us to actually showcase the harmonics up to 31 harmonics, and our mid-range power meters allow us to measure up to 19 harmonics. And also for that, we have another product called the Eco Web Server. This Eco Web Server, the advantages of it is three main points that we want to highlight. First is a simple setup where the customer itself can actually do their own installation, and also it displays the measurement data and the graph on the web browser, and it allows the automatic transmission of data collected and mail notification and contact output. So as you can see here, with just now the first case that we've highlighted, we have only basically managed to do some basic collection and basic of monitoring. But in this product itself, you can see that we can actually do collection, storage, visualization, and also publication on the web, and we can do analysis and monitoring. And this product also allows us to link all the products such as our Eco Monitor, our Power Meter into one integrated solution. So moving on for this Eco Web Server, we do have this Eco Advisor. This Eco Advisor is our new product, which is to complement our new Eco Web Server. This new product is actually to complement our existing Eco Web Server, where you can see that there are additional functions such as time series. There's also you can measure it through pie chart, through crossbar chart, scatter plot, histogram, and Pareto. So this new product itself also supports our Mail IPC, where there's a need for intelligent. It can also, if in the future you do need predictive AI intelligence, this software itself can also support this product. And the main advantages of using this is when we are doing our management reports to our management, it says that, oh, we can do various measurements and all that. So this will actually do advantage for those, especially in the facilities. So the next question we do face is that, let's say we do have the Eco Monitor where we do a basic monitoring solution, and we can do visualization as well as analysis. So now let's say we want to do on a bigger scale. Let's say we want to do it on a plant or building, or if I'm on the go, or if I'm, let's say I'm in other countries. Is that possible? So yes, we do like to focus that we do have another advanced management software where we can help for customers and end users for factories as well as buildings, called the MCWork software. And this MCWork software, some of the features of this at the factory level, that it increases the production line, and it helps to control the temperature and airflow via the aircon system and display the temperature and humidity measured by the sensors. And it also allows to monitor and to analyze the operations of production equipment that customers and consumers will have, where they can do troubleshooting. So this is one software that we would like customers who have actually have some problems who are facing energy usage at a bigger level, not just at a basic level, but at the plant level and factory level, to consider usage of this particular product. And also, besides at the plant level, we do this software at a building management level. So some of us may not be working in the plant level, some of us may be working in buildings. So inside these buildings itself, we can also do visualization of energy through building to the aircon system, the lighting, gas, and analyzing and recording the point of waste. And it also allows us to monitor the temperature, switching itself, heating, and control. And also, last but not least, for this particular product feature, we have remote monitoring for mobile devices, where the customer can do monitoring when they're on the go, and they do not have to be inside the facility. They can be out there, or when they're on leave, or when they are overseas, they can actually do constant monitoring. And with real-time information, any problems, they can actually troubleshoot it quickly. So we realized that, hey, now we know that we can collect data, we can also analyze, we can also monitor, but can we do full control monitoring that will lead to better productivity, or even we can lead to energy saving? And yes, we do have a new product that's coming out that's called the Eco Monitor Plus Control Unit. And this is actually a new device that's just we've just come up with, and it allows for two main functions. One is for the schedule control, and one is for the interlocking control. And as per the other softwares that we have mentioned before, this particular Eco Monitor Control Plus unit also comes with a new software. So what do we mean by schedule control or interlocking control? Let us look at some examples that we have that the user may face. Let's say now we are at the case of a utilities plant. Okay, we have a pump that is continuously operating because the warm-up operation is performed. And if the manufacturing is not done after the work time, the energy loss is occurring. So let's say now, so the solution that we have is to switch the power to on-off to enable the equipment itself to improve the energy loss. Let's say in an event where the months change, the days change, we can actually do our setting to meet, because every month we do have different holidays and all that. So we can actually do the setting to fit the particular month. And we can also control the pattern. Let's say, for example, I would like to schedule my operation on a weekday, or let's say I would like to schedule my time on a regular time basis, or I would like to schedule a total shutdown on a holiday when nobody is working. So by doing all these operations, we found out that actually we do have a reduce of a 2 megawatt usage, and that effect has led to a effect of energy saving. And let's say now we are working in a production line, okay, where the operation of the equipment is constantly moving, and let's say if there's a case of a shutdown itself, it's still operating, and all the time we can see that the energy is lost if this is not properly managed in an example of a mist collector. So same thing, okay, the solution is that miscellaneous, if we do better control management of the miscellaneous equipment, the energy loss will be improved. So we can, in this control setting, we can actually do the determination current, and we can set the condition, and once the condition has been satisfied, we can actually see the effect of energy saving here, where we can see the measured current of the production equipment, and this will constantly measure, and if there is a drop in the performance itself, the control unit itself can move into a shutdown mode where it automatically triggers the ability to do energy saving. And with this effect of this energy saving, we do see that there's also a 0.8 megawatt per hour per equipment per year. So you can see that there's an energy saving. So the analog function of this product is also can be demonstrated. Let's say now we are working in an office. Like some of us may not be in a production environment, some of us may not be in a process control environment, some of us may be in an office environment. And in an office environment, what matters to us most may be the control of the ventilation fan. Right? In this case, the analog output does its function to do energy saving as well as to measure the carbon dioxide concentration. And to do that, it does not exceed the limit, and we can actually control the fan to improve the energy losses. So by controlling the ventilation fan itself, we have found out that it generates about 13 megawatt per year of energy saving. That is a lot. So we did a summary of a study. We found that, let's say in the first case of a hydraulic pump, right, we do save based on 2 megawatt energy saving per year. We actually we helps the consumer to save about $500 per equipment. And in the case of a mist collector, we do have a savings of about $200 per equipment. And for office building itself, we do see a savings of about $3,000 per equipment. Although these figures are small, but let's say if we have more of such ventilation fans, more of such mist collector, and more of such pumps, you can imagine how much we can save in a year. So as consumers, we can see that besides we understand the importance of energy savings, and as users, if we can partake in the activities of this particular product, okay, we can generate a lot of savings over the years. So one of the takeaways that we would like to share with you, as what Waiman has mentioned before, he has mentioned on the inverters and all that, that all our equipment can be linked together, and together we can have a smart solution. So there are a lot of cases where we have different cases, all of us have different needs. So if you have any questions that you have some problems where you are not sure how do we go about to do this, you can give us a call, you can email to us, we will come down, we will actually try to integrate solutions for you, so that, because all of us have all different needs. Some of us do not need to monitor at a very high level, we just need a basic monitoring. Some of us do need to have analyze and do reports, or some of us do have to be constantly logged on to monitor the status. So, but how to do this linkage and how to do these solutions, right? Every case is very different. As you can see, we do have cases in Singapore where we just need basic monitoring, and in some cases in Malaysia where we need to measure at the plant level. So by integrating some of all these products together, we hope that this session you can combine to all these products together and to help you to save energy, as well as to benefit the user in the long run. So as what Waiman has mentioned, in the case of energy savings, if we do not start as users to first to monitor, to control, and to analyze, we will not be able to measure the importance of energy savings. And if we do not, as end users, start to do monitoring, we will actually end up paying for a lot of money. So therefore, we urge all users out there to consider first to do monitoring, and then in following that, we would like customers or end users to consider how to control the data, how to analyze, as well as eventually, if they want to do control, it will lead to overall energy savings. So I believe that another question will be out there for some poll. So to help us to better understand your needs, so that we can come and see you, or if you have questions to ask, we will see which are the main major concerns that is affecting you, and we would like to see how we can work together to integrate as a partner, as a solution provider. So here are our contacts for Waiman and myself. So feel free to contact us, and we hope to see you in the next webinar. Thank you very much.